knows a lot about the science stuff. Professor Dave explains.
Imagine a huge reference library with lots of books. They are sorted according to the subjects. There are lots of subjects and lots of topics within a subject. Searching for a book on a particular topic within this library would be a tedious task. What if there was a further subclassification based on the author's name, or division into different subtopics? Retrieval of a particular book would be a lot easier. Similarly, fingerprints need to be classified systematically to make the process of identification easier. In this tutorial, we will try to understand how Henry's classification of fingerprints works. As we learned when discussing the history of fingerprints, they were first officially used for identification in the Bengal province of India by Sir William Herschel. However, fingerprints were still not assimilated as a means of identification in criminal matters. The police used to rely on anthropometry, which involved observing and documenting bodily features and physical measurements for identification. This was despite anthropometry having its list of disadvantages and limitations, such as two individuals sharing a common set of physical features. But it was the consensus back then that there exists no better technique than anthropometry for criminal identification. This was when Sir Edward Henry was impressed by the obvious merits of fingerprints and started toying with the idea of using fingerprints either in addition to or instead of anthropometry. He discussed this proposal extensively with pioneers of fingerprint science, such as Sir Francis Galton. Henry realized that the current system of fingerprint classification was based only on their pattern types. There existed no method that sorted fingerprints in a scientific yet simple manner that would permit easy retrieval and rapid identification of a person whose fingerprints have already been recorded. This was one of the reasons why fingerprints were not inculcated into law enforcement. So Henry, with his subordinates, Sub-Inspectors Azizul, Haque, and Hemchandra Bose, worked extensively from 1896 to 1897 to develop a standard fingerprint classification system. It was Azizul Haque who proposed a mathematical formula to supplement Henry's idea of classification. The original classification system, as proposed by Henry, took into consideration all the fingers and converted the patterns present on them into the form of letters and numbers that could be easily arranged in the form of a fraction. Now that we are familiar with the background behind the system, let us understand it in detail. Henry's original system of classification involves four main divisions: primary, secondary, subsecondary, and final. Let's go through them one at a time. The first stage of classification is the primary classification. It is a 10-finger classification, which essentially means that all of the fingerprints from both hands are studied here. This fingerprint card is known as a 10-print card. Let's look at how the fingers are numbered on this card. Hold both of your hands in such a way that the palm of your right hand faces you while the palm of your left hand faces the opposite direction. Start counting your fingers from the right thumb to the left little finger. This is the order in which fingerprints are numbered on a fingerprint card. The right hand is numbered 1 to 5 and the left hand is numbered 6 to 10, from thumb to little finger. The primary division of classification is also known as the whorl division. As the name implies, this system only considers the whorl patterns present on your fingers. Each finger is assigned a numerical value, and that value is given to the finger only when a whorl pattern is present on it. Here, the term whorl pattern includes all the variants, such as accidental, central pocket, and a double loop. If a finger has an arch or a loop pattern, the value given to that finger is 0. The values assigned to the fingers are simple, as shown in this table. Starting from the right thumb, 16, 16, 8, 8, 4, 4, 2, 2, 1, 1. As you can see, the value halves after every 2 fingers. Easy to remember, right?
Adding up the values for even-numbered fingers, 2, 4, 6, 8, 10, generates a numerator. Odd-numbered fingers, 1, 3, 5, 7, 9, form the denominator. So the lowest possible value for primary classification will be 0 over 0, right? Actually, that's wrong. To avoid confusion between the numeral 0 and the letter O, which is used in ridge tracing to denote an outer whorl, 1 is added to both sums. So 1 over 1 becomes the lowest value, and 32 over 32 will be the highest value when all fingerprints are whorls. Azizul Haque, Henry's colleague, discovered a method to group a set of fingerprints in 1,024 pigeonholes according to primary classification. This setup was designed in such a way that there were 32 rows, with each row having 32 pigeonholes. Primary classification, though it technically generates 1024 combinations, or 32 times 32, practical limitations arise. Over 25% of people fall into the 1/1 category due to Worrell scarcity, underscoring the need for deeper classification. Secondary classification simplifies things by encoding patterns on the index finger. The right index, finger 2, dictates the numerator, and the left index, finger 7, dictates the denominator. Patterns are labeled A, plain arch, T, tented arch, W, whorl, U, ulnar loop, or R, radial loop. For example, U over U denotes ulnar loops on both index fingers. Next, subsecondary classification looks at index, middle, and ring fingers. Whorls undergo ridge tracing to determine if they're inner, I, outer, O, or meeting, M, based on ridges between the traced line and the right delta. Loops, meanwhile, are classified via ridge counts. Index loops with less than or equal to 9 ridges are inner, I, greater than 9 are outer, O. Middle loops use less than or equal to 10, I, versus greater than 10, O. Ring loops follow less than or equal to 13, I, versus greater than 13, O. Results from the right and left hands form a fraction such as IIM, IIO, thereby adding granularity. Then, final classification prioritizes the little fingers. If the right little finger is a loop, its ridge count defines the final value. If not, the left little finger is checked. For whorls, an ulnar loop is simulated by counting ridges between the core and the left delta. In practice, only one value is recorded. For example, a right little loop with 12 ridges yields a final classification of 12. This is how the classification is represented altogether: primary, secondary, subsecondary, and final. The line present in between the numerators and denominators is known as the classification line. Barring the primary classification, where even-numbered fingers form the numerator and odd-numbered fingers form the denominator, the rest of the divisions have right-handed fingers as numerators and left-handed fingers as denominators. 2 additional divisions were added later, known as key and major. Though being the latest to be discovered, these divisions are always represented before the primary classification so as not to disrupt the original order. The key is the ridge count of the first non-little finger loop, let's say 11 for a right index loop, and appears above the classification line. The major analyzes thumbs. Whorls undergo ridge tracing. For example, 3 ridges equals inner, while loops use ridge counts. Values for both thumbs, right above and left below, are noted. While Henry's system revolutionized fingerprinting, modern adaptations address its gaps. The FBI added subdivisions such as WCDX for complex whorls, and a special loops category. Digital systems now automate classification, reducing manual errors inherent in analog pigeonhole storage. Yet Henry's core logic endures: layered, hierarchical analysis that balances breadth and precision, proving even century-old frameworks can evolve without losing relevance.
Thanks for watching. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.